Jai Hind and welcome all of you to the chemistry class. Today we start a new chapter, the third one, electrochemistry. Electrochemical processes have a wide range of applications in our day-to-day life. For example, a large number of metals, sodium hydroxides, chlorine, fluorine, many chemicals, etc. are produced by electrochemical methods. Batteries are used on a large scale in various instruments and devices. Therefore, study of electrochemistry is important for creating new technologies. Then, I ask some questions. What is a redox reaction? Which form of energy is converted into electrical energy in dry cells? How is NaOH manufactured from sodium chloride? Do you know? Yes. First, redox reactions are reactions in which oxidation and reduction occurs simultaneously. The second question, which energy is converted into electrical energy in dry cell, which means chemical reactions takes place, then electricity is produced. That means chemical energy is converted into electrical energy. Then the third one, NaOH is manufactured from sodium chloride by electrolysis. By passing electricity, that means by using electricity, chemical changes are carried out. In the second question, the chemical energy is converted into electrical energy, and in the case of third one, the electrical energy is converted into chemical energy. That is known as electrochemistry. So, electrochemistry is defined as the branch of chemistry which deals with the interconversion of chemical energy to electrical energy and electrical energy to chemical energy. That is, it is the study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformations. In the case of spontaneous process, which means there is no need of external agency, that is, all naturally occurring processes are spontaneous one. Here, chemical energy is converted into electrical energy is a spontaneous process. But in the case of the second conversion, electrical energy to chemical transformations, the external electricity is required, so it is a non-spontaneous process. So, electrochemistry deals with the interconversion of chemical energy to electrical energy and electrical energy to chemical energy. So, these interconversions are carried out by using some devices known as electrochemical cells. Electrochemical cells are of two types, electrolytic cells and galvanic cells. First one, electrolytic cells. Cells which convert electrical energy to chemical energy are known as electrolytic cells. This conversion is a non-spontaneous process. The second one is galvanic cells. The cells or devices which convert chemical energy to electrical energy are known as galvanic cells. This conversion is a spontaneous process. First, we studied about galvanic cell. The best example for galvanic cell, Daniell cell. Daniell cell is the best example for galvanic cell. Daniell cell consists of a zinc rod dipped in zinc sulfate solution and copper rod dipped in copper sulfate solution. Zinc rod and copper rods are known as electrodes. These two solutions, that is zinc sulfate and copper sulfate, are connected through a salt bridge. It is an inverted U-shaped tube which complete the internal connections. That means salt bridge complete the internal connections and the metal electrodes are connected by a metallic wire
through a voltmeter and a switch externally.
Daniell cell consists of two portions, that is, two half cells. The first one is zinc rod dipped in zinc sulfate solution. That is the first half cell. In this case, zinc metal has a tendency to go into the zinc sulfate solution and it becomes Zn2 plus ions. In this case, two electrons are released and these two electrons move through the metallic wire externally. This electrode has negative charge because in this electrode the electrons are released. Here you can see the movement of electrons through this metallic wire. This electrode has negative charge also. Then here loss of electron takes place. This process is known as oxidation. Oxidation means loss of electron. Here zinc is lost its 2 electrons to form Zn2 plus 2 electrons. Here oxidation is loss of electrons. Then where this oxidation takes place? The oxidation takes place in anode. The code is ANOX. Oxidation takes place at anode. So, oxidation is loss of electrons and the oxidation takes place at anode. So, this half cell is taken as anode in which loss of electrons occurs known as oxidation. Here, anode half cell reaction is zinc lost its 2 electrons to form Zn2 plus 2 electrons. These 2 electrons are released through this metallic wire. Then the reaction we can written as zinc gives Zn2 plus 2 electrons. The next half cell of Daniell cell is copper rod dipped in copper sulfate solution. You know, copper sulfate solution consists of Cu2 plus and sulfate ions. The 2 electrons released from anode half cell is come to the solution and accepted by Cu2 plus ions to form copper atoms. Here you can see the reaction takes place at anode is Cu2 plus accept 2 electrons to form copper atoms. That is, here gain of electrons takes place. These copper atoms are deposited on the surface of copper metal. This half cell have positive charge because the electrons are accepted by this half cell. So, these have positive charge. Here in this half cell, reduction takes place. Reduction means gain of electrons. Reduction is gain of electrons. So, that is reduction. Where this reduction takes place? Reduction takes place at cathode. That means, see the code, reduction takes place at cathode and reduction is gain of electrons. You know the half cell reaction Cu2 plus accept 2 electrons to form copper atoms. That means here gain of electrons takes place. So, this reaction is reduction and reduction takes place at cathode. So, this is the two half cells present in Daniell cell, zinc rod dipped in zinc sulfate solution and copper rod dipped in copper sulfate solution. Two solutions are connected through a salt bridge and this two metal rods are connected through a voltmeter externally. Here the zinc rod dipped in zinc sulfate solution is taken as anode and this has negative charge, and the copper rod dipped in copper sulfate solution is taken as cathode and have positive charge.
Electrons move from anode to cathode, so the current flow is from cathode to anode. The current flow can be noted from this voltmeter. Here we get the output potential of Daniell cell is 1.1 volt. That is, from this connection we get the output value 1.1 volt. Here oxidation and reduction takes place simultaneously and also electricity is produced. The half cell reactions in Daniell cell, anode half cell, zinc is converted into Zn2 plus 2 electrons. In cathode half cell, Cu2 plus accept 2 electron to form Cu. Then the overall reaction or net reaction is, on adding the left side of two equations, then we get the LHS of overall reaction, and on adding right side of two equations, then we get RHS of the net reaction. Then we get zinc solid plus Cu2 plus aqueous gives Zn2 plus aqueous plus Cu solid. This is the overall reaction takes place in Daniell cell. This is the working of Daniell cell